Welcome everyone. So let's get started and talk Android performance. I guess that there are not so many Android developers at Devoxx, otherwise the room would be packed because everybody complains about the performance of Android builds. I expect so. So how many of you are already using Android? Okay, so pretty much everybody. And how many of you have Android issues during build times, sync times in Android Studio or command line? Okay. So that's a good reason to come to this session. So unfortunately, this will not be a free lunch, so you will not come after this session, copy and pasting code, and expect the build to be faster. You will have to do some work, and we will explain actually how we did that at Gradle. So first, a few words about Gradle. Just a comment, because often Android developers actually don't understand the difference between Gradle, Android, and Android Studio in particular, and the Android Gradle plugin. So Gradle is a generic build system, and it can support different environments, not just Android, so native builds, Java, we do Kotlin, we go C++, Go, whatever. So this is just a generic build tool, and it happens that Google chose Gradle as its main build tool a few years ago and built a plugin which is called the Gradle plugin for Android, and that runs in Android Studio, right? And this plugin connects to Gradle, and then things happen. And we will try to understand what happens there. So Gradle is also backed by a company which is called Gradle Inc., and I'm working at Gradle, and I've spent, I think, almost a year working on performance at Gradle, in particular improving the performance of Android builds. We do consulting, and actually we also hiring, so if you're interested in this build domain and you find the challenges in this area interesting, come talk to us, and we would be really happy to discuss with you the opportunities that we have. So first, we need to think about why we want to optimize builds. And the first reason and the main reason is cost, right? So this is just a simple equation, and you have 16 seconds waste, you do 50 builds a day, you have 50 developers. In the end, this is 42 hours wasted time. And 42 hours is basically one engineer. So depending on how much you waste, actually this is productivity that you lose, and maybe this is also manpower that you lose. So you could hire someone to do the same thing for the same price. So this is really super important to take all the performance issues that you have into account and optimize everything so that you don't see those problems during your daily work. So during this talk, we are going to explore how to improve performance, but for that, we have a process to follow. And the process to follow is this one. First of all, you need to decide what you need to improve. So you have a problem, you need to identify this problem, and only this problem. So maybe your main issue today is the Android Studio sync time. It takes, I don't know, minutes, and it shouldn't. So this is a problem we often see, and well, something is happening, you need to improve that. Or maybe it's actually something different. You have a single module build, and each time you change one file, it takes 10 minutes to build. And for one file, honestly, 10 minutes to build is a bit excessive. So maybe you need to improve this process. So this is something that you really need to decide first. Then we're going to profile. Then something interesting is identifying the biggest bottleneck, because that's a big because. Often you have different performance issues, and because you are familiar with one problem and one thing that you see, you're going to say, yeah, I'm going to fix this one because it is easy to fix. But maybe this problem is only, 10% of your build time, and you have something that takes 80%. you should probably focus on the 80% first, because if you can improve that and reduce that by half, it would have a significant more impact than just doing that on the 10% one. Then you fix the bottleneck, obviously. And step 5 is really something that you need to do. Verify that the fix works. Often we see people just changing some code and thinking that it's going to work, and in practice, never checking that it does, and sometimes it makes things even worse. So make sure that you do that. Repeat the scenario again and again, and improve your build times during that as in cycles. So this may be easy, but actually this is not something that we say just like that. I mean, this is the exact process that we have followed at Gradle to improve the build performance working with the Google teams. So it's been now 2 years that we work with them and have close relationship to improve the build times. And the process that you see there is valid for a customer, so like end user for you, but it's also the process that we follow at Gradle with the Google team. So we identify the biggest bottlenecks in the builds that we see in the wild, and then we have tools that help us and that we're going to show can help you. So, of course, if you want to be serious about performance, you have to be serious about the tools that you use for performance. And one way to do that is to automate every measurement. You don't want to run the build 70 times just to check if it improves time. You want to be sure that it works, and for that, we have automation in place. So if you go to this GitHub repository, we have a tool that is called the Gradle Profiler, and it takes a configuration file that you see there. And basically what it lets you do is to define some scenarios. So we were talking about the scenarios in the first slide. This is where you define the scenarios. So I'm defining a scenario which is going to approximate the configuration time by running just the help task on Gradle. Another one is just simulating the sync time in the IDE. Clean build, what happens if I enable the build cache, etc., etc. So you can define a list of scenarios, and then the profiler is going to run this, execute the build several times. Maybe you're going to have things like, I want to change a single file, and the tool is handling that. So handle the scenario where actually you update a file, run the build, and it should be fast, and it's not. So you need to use this tool, and the good news is that this is the tool that we use internally, and if you have a build which is slow, this is going to generate a profile that you can send to us, and we can look at it and actually analyze the bottlenecks in your build if you're not really able to deal yourself with those numbers. So now that you have those scenarios and that you have the tooling to do that, there's something really easy that you can do as a first step to improve the performance, and the first thing that you need to do is actually to be up to date. I was saying that we work with Google to improve the builds. We do, and actually every 6 weeks we have a new release of Gradle, and each release comes with performance improvements. And when I'm saying that, I mean we measure the performance improvements. So we have tons of builds on CI that actually make sure that we never regress. And if there's a regression, actually it is documented. So please update. The latest version, I think, which is supported by the latest public release of the Android Studio plugin is 4.10.2. So first step, upgrade. And I should say that in Android Studio, it's actually something that you have to do because it's often pinging you, telling, hey, you need to upgrade this Gradle version because you update just the IDE. Second point, how many of you have tweaked the JVM arguments to make the builds faster? Don't do that. In 99% of the cases, this is wasteful, right? You find tons of questions on Stack Overflow, and people think to be smart and say, yeah, if you use this parameter tuning of the JVM, like, I don't know, setting soft reference cache to 0, then it's going to be faster. This is not true, right? The only thing that you have to do is make sensible defaults for memory for your build, and it's going to work nicely. The defaults that we use at Gradle are really, just what you need to tweak. So often, this is really funny because often people say, yeah, actually, I want 1% by doing that. Yes, maybe, but if you could cut your build time by half, just investing some time investigating, it's much worth your time. Sorry. The next thing that you have to be aware of is that we have something called the Gradle Daemon, which is not necessarily visible if you just run from the IDE. And the Gradle Daemon is something that runs in the background and is actually running your builds. But when it finishes a build, it stays there. So often you see people complaining and say, hey, Gradle is staying there in the background. We stay there for a good reason, because every build that you're going to run, the next build is going to be faster and faster just because of the cheat and all the in-memory caches that we have. So it is absolutely necessary that you keep the daemon on. Some people disable it because of whatever reason. If you are one of those people, there is a problem with your build that you need to fix, right? Either it's a faulty plugin, or actually you're maybe leaking a file handle and Windows doesn't handle that. That's a problem. So the next build is going to fail because you cannot have a lock on a file. This is not right. This is what you have to fix. So instead of disabling the daemon and wasting hours of development time, find the issue and then fix it. And maybe it's a plugin, so you have to report it to GitHub or whatever. Something to mention too, it works on the CI server, so you can enable the daemon on server. We do that at Gradle. And it's been, I think, 2 years now that we have been enabling the daemon by default on the CI servers at least. Okay, so now you have identified a scenario that you want to improve, and what is the problem? So the first tool that you need to be aware of, well, second after the profile, of course, is something called the build scans. How many of you know about build scans? Okay, so just a couple. So build scans is really a powerful tool to get all insights possible about a build. So when you run a Gradle build, you can generate something that looks like that. And it collects information about everything that happens during a build. So the logs, the console output, it will tell you all the dependencies that you use. It will tell you how many builds have been run in the daemon in the background. It will tell you if you're using deprecated features, so all kind of insights about your build. And this is the tool that we are going to use here to debug our performance issues in Android builds. So this one is actually something which is public, so it's not an Android project, but it doesn't matter. Build scans are free to use, so if you have a build, you can just run it with --scan, and it's going to generate something like that, which is published on scans.gradle.com, which is a public instance, so be aware of that, right? So if you have a project and you don't want to leak some information to the public instances of Gradle, well, try this on a pet project first. What it will give you is some insights like this one. So Gradle has some different execution phases. One is configuration, one is execution, to simplify. And build scan would tell you every time that is spent in each of the phases. And with this drill down view, you can actually know what is happening during the build. And sometimes it's slow for a very simple reason, like, I don't know, but my memory usage was maybe a bit too excessive and I'm hitting the limits of the daemon. And I'm spending time in GC. So we've seen that in the wild. Someone was really complaining and being very vocal and saying, my build is taking 30 minutes when I change one file. 30 minutes, okay, what's happening? And actually, when you look at the build scan, it was pretty obvious, it was spending 99% of its time GC time. So it just increased memory and then done. Problem is fixed. So with this view, there are already some things that you can deduce and help you identify what are the big issues in your configuration, execution time, etc., etc. So first and foremost, if you have a startup time which takes more than 1 second, you have a problem. It should never exceed 1 second, right? So I don't know if it's the case for you, but if your startup settings evaluation and build source execution takes more than 1 second, you have a problem. You want to look at this. Then you have the configuration time. And this is a bit trickier because you have different builds. I guess for some of you, a single monolith application. Others will have 50 modules. The hint that we say in general is that if you have a configuration time of more than 10 milliseconds per project, there is probably something that you can look at in this case. Third one, this is what I've been talking since the beginning, but if you change a single line of code and the time it takes to build the application is more or less what it takes if you take a clean build, then you have a serious problem there to solve. And the good news is that often it is super easy to fix, because Gradle is really serious about the performance, and it does that by being incremental. So if you have this problem, this probably means that you have one task which is not incremental at all, and you want to know why. The next point is actually related to this. I don't know if it happens to you, but with Gradle, if you run a task, then compiles, maybe it takes a minute, I don't know, because you have a lot of files to process. Then you run again, and again, 1 minute. There is something very wrong there, because Gradle is incremental. So if you don't change anything, it should be instant. It should be 0, right? It shouldn't do anything if you don't change something. If something is happening, if you have longer configuration time, longer execution time, then you have something to fix. And the last one is the one that I mentioned earlier, GC time. Okay, so I have identified that the startup build source settings file is too slow, takes 1 or more seconds. What could happen there? Well, often the single thing that you can see is actually that the daemon is disabled. So here with the build scan, it would tell you exactly how many builds were executed in the daemon. And sometimes you would realize that the daemon is there, but it has been executing 100 builds, and it's slower and slower as you execute more builds. This hints at a leaky plugin or something that leaks memory, and actually it's growing over time, and then in the end, the daemon is not able to run anymore. So usually Gradle is smart enough just to shut down the daemon itself and respawn a new one. Sometimes it just doesn't work, just be aware of that. So make sure that your daemon is healthy. Then we come to the biggest point, and this is where you should probably investigate most time, because this is where we see the most issues. Configuration time. So configuration time is really the time that Gradle needs to understand the structure of your project. So say you run assemble debug. So you go on the command line, or you do it from the IDE, assemble debug. What does it mean? It means that Gradle has to evaluate everything, configure a number of tasks based on the number of variants that you have, and it's going to configure the tasks, execute something to build a task graph in order to know in which order it's going to execute each of the tasks. And this should be really fast, right? It's just basic graph execution and applying some configuration. And it includes applying the plugins, evaluating the build scripts, and potentially using the after evaluate blocks. So this is most likely for plugin authors, but we've seen that also in builds happening. So this is the only thing that it should do. So if you run Gradle help or Gradle tasks, this is more or less an evaluation of how much configuration time your build is doing. So just run this command, and it's going to tell you, yeah, configuration time takes 10 seconds. Wow, I have a problem there, because it told me it should be pretty quick, like milliseconds. So one of the biggest issues we see is this resolution happening at configuration time. So you know that Gradle handles dependency resolution, so it's going to look at the external repositories and resolve all the dependencies and transitive dependencies and things like that. But you don't want that to happen at configuration time. It's only if you execute a task that you want to get the dependencies and maybe download them, etc., etc. So if this happens at configuration time, it is slowing every single build that you're going to execute, right? So instead of being executed just for the task that you need, it's going to be executed for every build. So it's just wasted effort. So a build scan would tell you, actually there's something that I don't show there, but there's a performance tab, and it would tell you, hey, something is wrong because dependency resolution is happening at configuration time, and it would tell you which configuration is being resolved. So it hints you at what is going on there. And this is a typical problem that we see. So you have a task saying uberjar, and here I'm saying that I want to create an uberjar from the runtime dependencies. And you see this .collect here. And .collect in Groovy in particular is eager. So it means that when the configuration block here is executed, this is going to iterate over all the files that you have in the runtime configuration. And then we do packaging of zips, etc., etc. But this implies that Gradle needs to resolve the configuration in order to execute. So how do I fix that? It's actually pretty easy. You just need to add this bracket here, and this makes it lazy. So instead of doing that at configuration time, now it's only going to execute that when the task is going to be executed. So this is simple to fix, but not necessarily easy to find. So this is why the build scans help there. Second thing that we are seeing often is this, I/O at configuration time. So Gradle is pretty smart and tries to avoid all possible I/O during the configuration. So we avoid reading files. We don't touch your build scripts if actually they didn't change. We don't recompile them, etc., etc. We have in-memory caches in the daemon, etc., etc. So lots of things that we do to avoid reaching I/O. So you don't want to do that, because if you do, then it starts getting slower and slower. So the build scan is telling me, actually for this build script, 0.2 seconds, that's a lot. Shouldn't happen. So what is going on? And then I'm finding this task, and it's a stats project. The task is supposed to compute the number of source files, right? So can anyone tell me what is wrong with this task? Nobody? It's missing something super important. It's missing the do last block. Do last tells you this block inside is going to be executed when the task is called. If you don't do that, it's done at configuration time. So it means that even if you don't execute the task, this is going to compute everything. So actually the task is executing during the configuration. So it's not a task anymore, it's just something that executes every time. So the 2 seconds, the 0.2 seconds that we had is actually the time it takes to compute and go deep into the directories and compute all the sources that we have. So the do last missing is something that is really important to figure out. And actually we have other recommendations about that. The recommendation that we give is actually if you want to have inline tasks, create a class to model what the task is doing. Because this way, if you do it this way, you cannot forget about the do last block, because everything you do is actually in the task action. Second point, what you do is actually explicitly declaring the inputs and outputs of your task, and it means that you tell Gradle about the incrementality of this task. So it's going to know that the sources is an input and that the stats files is an output. So if you remove one of them or if you change one of them, then only in that case Gradle is going to re-execute your task. We would also recommend to put that file, that project start task into the build source directory so that you have real separation of the declarative aspect of Gradle, so the configuration of the task just in a build file, and then the actual code doing the execution in a plugin. And speaking of plugins, this is also something we see often. So inefficient plugin. What does it mean? This is actually something real from a real project that we've seen. So there was someone thinking that it would be fun to have some generic facts every time you run a build. And actually, it was quite slowing down every build, so 0.5 seconds for every build. And this same build is actually doing something very strange, because, well, not very strange, but quite common actually. It is computing the git hash and using that as a version number. I know that this is a pattern which is pretty common, which is pretty fine. I mean, it's just fine to use the git hash as a version number, but then be aware how you do that. Because if you do that like this, I have a task that is going to actually execute git, get the output, and then put in a version, and then you apply this on all the subprojects. You are actually calling git a number of times. So doing IO a number of times. And this is not good for performance because actually there's no need for that. The hash is going to be the same for every project. So instead, what you want to do is do it once. So compute the version, set it into the main project, the root project, and then for the subprojects, just copy that value from the one that was computed. So you only call git once. And by the way, there's a plugin to do that, so you shouldn't have to do it yourself. Something which is more specific to Android. So Android is known for the variant management, and sometimes you have just an explosion of the number of variants because you create custom types, I don't know. And actually some combinations do not make sense sometimes. Like you don't want to send a debug variant on production. It doesn't make sense to have this. And actually Google provides an API to filter all the variants that you don't need. So use this API because it significantly decreases the configuration time. Because for each variant that you have, it creates a lot of tasks. You probably noticed that. Okay, so now we want to make the build a bit better by optimizing the build script logic itself. So first, try to do things like this. Try to modularize your build. And it means you can combine different aspects of the build into different build scripts and explode the different aspects of your build in different build scripts. This is not just for organizing code and recognizing better how just better organization. It's also about when you have insights in the build scan, it's going to tell you actually this is happening in this build script. So it's much easier to narrow the problem and to find exactly what file is faulty when you find a performance problem. As I said, if you write plugins, try to use build source because this is also quite optimized. So we try to precompile and cache everything. Also, use static compilation. So it doesn't matter if you use Java, Groovy, Kotlin, Scala, whatever language you want to write a plugin, but it is much preferred to use a static language to do that, because dynamic Groovy is nice, but it's unfortunately quite slow. So use static compilation. Last, that's what I mentioned earlier. So if you do that, it helps you keep your build mostly declarative, which is nicer for you and for the future you reading your own build files 5 years later. Then you may find a real problem. How many of you know about flame graphs? Have seen these before? Okay, so this is something that you can get from the Gradle profiler, and Gradle profiler is going to use whatever profiler you want. So it can be JFR, it can be YoKit, it can be, it integrates with different tools, and it can generate an output like that, and it actually tells you what is consuming time. So I've identified that you have a problem, but here, actually, this build is pretty sane, because the most of the time here is spent in generating the variance, right? So this is the Android plugin generating variance. So it means that maybe if you're falling into this trap, maybe use the variant filter just to reduce the number of variants that you have. And then we come to execution time. So this time, configuration is okay, and we want to execute the task, and so what can happen? First, Gradle is meant to execute only some selected tasks, so it will not execute whatever is not necessary for a single task. It is meant to be incremental, it is meant to be cacheable, and parallelizable. So these are the tools that we're going to use to make the build faster. So first, incremental builds. If you see this after executing the same build twice, you want to fix this. This should never happen. You don't change something, should be 0. And good news is that the build scans will tell you what happens. So I'm using build scan, I'm clicking on this task, and it tells me, the task wasn't up to date because version codes has changed. And okay, where is this version code file coming from? Actually, that's something that you probably see. How many of you use Crashlytics? Okay, so Crashlytics actually generates a new ID for every build that you run. It makes sense if you release, but for development, you don't care. And the problem is that because it does that, it invalidates all your builds. So bug them and tell them just to do this by default for the debug variants. Don't apply this ID generation because it just slows down your build for nothing. In general, timestamps, unique IDs, etc. This is really, really bad for performance of Android builds and performance of builds in general, because it defeats all the incremental caching that we have. So, yeah. Second, faster compilation. So it used to be the case that Gradle wasn't so nice with a lot of different modules, submodules. This is not the case anymore. And actually, it's quite the opposite. Modularize your build. So if you have a monolith, you absolutely want to split that into smaller modules. Make it 10 modules, make it 50. Make it smaller as possible. This is also about decoupling a code, but Gradle is pretty smart actually about what it does. It has the concept of compile avoidance, so it's smart enough to understand that if you have dependencies between modules, it doesn't need to recompile if, for example, the only thing that changed is an implementation detail of a dependency, right? It's going to say, hey, actually, this is just the implementation, so I don't need to recompile the consumer. But if it's the ABI, so the interface, the APIs of all the components we have changed, then it needs to rebuild. So by having just a single monolith build, you just don't get this. So it's pretty terrible for your performance. Decoupled code, of course, and it leads also to faster incremental compilation. So Gradle now has a Java incremental compilation by default. And unfortunately, it used to be the case that there was a bug, well, so upgrade to the latest Android build, Android Studio build. But now it's safe. How many of you migrate to Kotlin to build their applications? Okay, so if you do that, just be aware, migrate everything at once in a single module. So the Kotlin compiler has a big problem. It is very, very slow if you have joint compilation between Java and Kotlin. So if you do just pure Java, it's fast, pure Kotlin, it's fast, but mixed doesn't work well. So just be aware of that. The JetBrains guys are fixing this. In the meantime, yeah, a single module should be a single language. Next, I should turn the question the other way around. How many of you are not using incremental annotation processes? Sorry. So everybody in the Android world is using annotation processes. The problem is Gradle doesn't know what is happening when you use an annotation processor. I mean, it could be just scanning the whole disk. It could be generating random files in random directories. We don't know what it is doing. So if you have an annotation processor, the problem is that it disables all the incremental compilation that we have with Gradle. Bad news, right? But there's a good news. Since Gradle 4.7, we provided a way for the different annotation processor authors to tell us, hey, actually I'm safe using incremental annotation processing. So they have to opt in, and once they have opt in and told us what they are doing, actually we can enable incremental annotation processing. And this is a game changer. So if you are using Lombok, Android State, Dagger, or Parseller, you're pretty safe because they released new versions which support incremental annotation processing. If you are using a different annotation processor, go to this GitHub issue. It links all the annotation processes that we know in the Android world, and it links to GitHub issues for them to fix their projects. And yeah, just go back them, tell them, actually, when I'm changing a single source files, for me, it takes, 5 minutes to rebuild. This is not acceptable, right? You want your builds to be fast. So come to them, tell them, please just tell Gradle what you're doing with your annotation processor. So there are quite a few open pull requests, and sorry if you're not on this list. Next, build cache. So caching is extremely important, especially in the Android ecosystem. So Gradle is really nice because it has the build cache, and the build cache can be shared. It can be on a cache node, on a CI server, and then all the developers can actually fetch what has been compiled by the CI server or even tested by the CI server without doing anything. So a typical example is that you have someone pushing some code on CI, on the VCS, then the CI builds, and then someone checks this out. And because the CI has done that, you don't want to do it locally. You can fetch everything from a cache. So we provide different caching strategies. With Gradle Enterprise, actually, we do have smart replication strategies. If you have a distributed team, we can distribute the cache between different nodes in the globe. So pretty nice things to do. So make sure to use the cache, the build cache. Then if you see something like this, parallelism, you probably want to make it better too, because Gradle can execute things in parallel. So this is a serial execution, so you're basically wasting all the CPUs that you have on your laptop. So how do I fix that? Actually, it's pretty simple. Just use -- parallel. But if you do that, you need to be aware that you need to have multiple modules, because by default, the only thing that we can do is to build different decoupled projects in parallel. So we do have some APIs for plugin authors to do that within a single project, and it works already. But in general, you just use -- parallel, make sure that you have decoupled projects, and it goes way faster. Okay, So now we have found our issues, maybe we've done some profiling, fixed the problem. This is good, but that's not enough. We need to keep track of performance, and we need to make sure, just like we do at Gradle, make sure that you never reintroduce problems. So how do you do that? Again, we have a tool to do that, and actually because we collect the information for every build, we can keep track of everything that is happening. So you can tell me, yeah, but actually I do have a CI server that does that, right? It knows all the history of builds, but it's only on CI. Often you never know what is going on the laptops of your developers, right? You never know, because maybe they are doing things that you never see because it's not done on CI, and actually CI is maybe pretty safe, but builds on laptops are failing for whatever reason and you don't know. Well, you can collect this information, and what you can do is say, okay, please Gradle, show me everything that you have around local builds that use clean. Because maybe one of the issues you have is that a colleague of yours comes from the Maven world and is used to use clean every time, because that's the only way they do it. So clean build, clean build, clean build. And maybe you just have to educate him to say, okay, this is fine. You can just remove the clean build thing because Gradle is safe and incremental, so don't do that. Or maybe they do that for a purpose. They do that because there's a bug, you know? So you need to identify that, and this is a tool that lets you identify and figure out that some people are doing something wrong. Next, deep insights. So watch performance over time, so you can get a timeline like this. And what we see here is that this comes from the Gradle build itself. So this is something that happened in real life. So we had for a period of time something going on, so every flatline, this flatline, so everything's safe, and then something goes wrong there. So you see, yeah, something is going on, and this is not just on CI. So this is not a problem on our infrastructure. This is happening also on the laptops. And the problem turned out to be a real thing, so it wasn't a bug, it wasn't a problem. This was actually us migrating our build scripts to Kotlin. So as we do that, we have to recompile everything. So it was perfectly fine, but this tool could let us get insight about what is happening, and we could keep track of the performance over time. And most importantly, maybe there is a real problem that you want to fix if you still start seeing build times increasing. So, last, we want you to give, we want to give some resources that you can use to handle all these performance issues with the Android world. So first of all, we have a generic performance guide, which is not specific to Android, but repeats more or less what I've explained here, and explains to you that you can use the Gradle profilers and there's the snapshots, etc., etc. And then there is a performance guide which is written actually by the Android team and explains how to optimize your builds with Android Studio. If you're writing plugins in your company, not a lot of people are actually aware of that, but we have a plugin development guide that explains the best practices. And in particular, we are moving towards more and more laziness. So Gradle provides some really smart APIs, and sometimes just not aware of that. So just to give you a hint of where we're going to, so we are developing APIs just to avoid configuration itself, just by being lazy by default. So we wouldn't even configure a task if it's not going to be executed. And as a plugin author, you want to be aware of that. And the last one is actually some best practices around how to organize build logic. So explaining how you should split your build logic just to make it easier to maintain and to keep track maybe of performance in the long run. Last, this is the URL that you have to capture. Go to scans.gradle.com. It explains exactly what you have to do to get this. Again, if you use the public server, this is for free. You have it. You just add --scan, and it's going to generate a build scan for you. And if you cannot do that because you don't want to expose your APIs or dependencies that you use, or even the infrastructure, well, talk to us, and we have GE, so the Gradle Enterprise version that you can install on-premise. And thank you, and we have 5 minutes left for questions. I don't see much. Sorry, the light. No question? So, thanks. I'll see you now.